types of data independence. It includes physical data independence and logical data independence. If you are making any changes to the internal level, that should not affect on the conceptual level as well as that should not affect on the external level. So data model is a collection of conceptual tools for describing data, data relationship and data semantics and constraint. Hello everybody, a warm welcome to one and all. I welcome you all to the session 3 and chapter 13, that is database concepts. I am Rohini TS from the Department of Computer Science, Vidhyaashram PU College, the Temple of Excellence, Mysuru. So in the previous session of this chapter, we have discussed regarding the data types of DBMS. And also we have got to know that what do you mean by database management system. So as we all know that it is different from database. So database management is a software. Database management system is a software that will going to take care about all the databases. So that's why this is differ from that is database is different from DBMS. And also we have discussed regarding the features of database and also we have learned regarding the data abstraction. What is the another name for data abstraction? That is three-layer architecture, three-layer RDBMS architecture. And also we have discussed regarding the DBMS user and data independence. So in our today's session, let me continue with this data independence. Along with that, we will be discussing about the different types of architecture and database models. So in that database model, we have hierarchical model, network model and relation data model. So we'll see about the data independence. So as we discussed in the previous session, data independence, as the name indicates, independence in the sense what? If I am doing any change to any of the layer, it should not affect the previous layer or it should not affect the higher layer. So that scenario will be termed as what? Data independence. So you can see here, it is a capacity to change the data at one layer that should not affect the data at another layer. That will be considered as what? Data independence. So there must be a independency between one data to another data which is in different layers. So if I am making any changes to one of the layer in any of the data, it should not affect another data of any another layer. So that is related to data independence. Here we have two types of data independence. It includes physical data independence and logical data independence. So now you can see the schematic representation of what is the classification of data independence. So as I told, it has two categories. One is physical data independence and another one is logical data independence. So when it comes to the physical data independence, here we have a file organization and data model is there and also it includes the database architecture. When it comes to this side, that is logical data independence, here we have a normalization rule which will be based on the relational data model and also we have a entity relationship. We are going to call that in short as a ER. This is the different types that we have in the data independence. So now we'll see about the first type that is related to physical independence or a physical data independence. So it is the capacity to change the internal level without having to change either the schemas at the conceptual or external level. So as I told, independence is what? There should not be a dependency between one data to another data. It should not get affected by changes of any data at any layer. When it comes to the physical data, it will going to be operated with a zeros and ones. And here it will be the core of a database. So it has a capability or a capacity in order to change internal levels. So consider I have a internal level and we have a conceptual level and we have a external level. So if you are making any changes to the internal level, that should not affect on the conceptual level as well as that should not affect on the external level. So that capacity will be termed as what? Physical data independence. And also changes to the internal schemas may be needed because some physical files had to be reorganized. So if you consider the data abstraction, already we have discussed regarding the three-layer RDBMS architecture. There we have a physical level, conceptual level, and also we have an external level. So in the physical level, we will be having a collection of records, we will be having a collection of files. So when I'm going to have this changes to the internal level, when I wanted to make a changes to the internal level, only if I wanted to change or if I wanted to reorganize the file which is already resides in this internal level, that is also called as what? Physical level. So here I'm going to have number of files. If I wanted to reorganize it or if I wanted to do any of the modification to the files which is existed in the internal level, at the time we are going to go with the changes with respect to the internal level. But if I am doing all those things, it should not affect conceptual level as well as the external level. And also this physical data independence refers to the data insulation of an application from the physical storage structure only. So it is easier to achieve than the logical data independence. If we consider a physical and logical, at the time physical data independence is somehow easier than the logical data independence. So in the physical data independence, we are going to insulate or we are including the application from the physical storage structure. That's why no need to worry about any other tables, no need to worry about any other files. So we are doing it internally. That will not going to affect any of the external or conceptual levels. That's why it is considered as easier method than the logical data independence. So here you can see the different types of file organization. So when you consider the physical data independence, at that time you can see that. So it has been classified into three types, that is file organization will be there, data model as well as database architecture. Now we are looking into this file organization. So in the file organization, it has two methods. One is what? Sequential access, and another one is random access. You consider I have a file and I have a content in that file. I wanted to access this. That can be for any purpose, like I wanted to modify the existing content, or I wanted to add a new content, I wanted to remove all the content. Whatever I wanted to do with a file, I just wanted to do that. How can I do that? With the help of two methods. One is sequential access and another one is random access. So in the sequential access, we have a self-direct addressing and also we have a sequential access based on the keys. When it comes to the random access, here we have a direct or a self-address generation method and we have a ISAM, very important topic. I will let you know what is this ISAM is all about. Okay, so we'll see the first type, that is related to serial file organization. As the name indicates, serial in the sense what? Sequential. It will be one by one. So we are going to access the file one by one, and the storage of that file is also going to be one by one. So in serial file organizations, records are arranged one after another in no particular order. So here we are arranging the data or we are arranging the file or records one after another without any order. For example, if the transaction 1 is coming first, then I will take that. If the transaction 7 is coming second, I will take that. That means there is no order. We are not using any order, but whatever comes first, next, based on the priority or based on the first come first serve method, we are taking that content or we are taking that record. So that will be termed as what? Serial file organization. That means we are organizing the file one after another sequentially, but there is no order. It will going to be first come first serve. Those who are coming first, those record which is coming first, that will going to be stored one after another. So it will not going to have any of the chronological order which the records are added to the files. And also here organization is continuous and simple because it is in the serial file organization method. Serial in the sense sequential, and it will also going to be continuous in nature and somehow it will be simple. So here data processing which requires the use of all the records is best suited to use this method. For example, I have 100 files or I have 100 records. I wanted to access all the records. At the time I have to go with this serial file organization. Why? Because in this method data processing, I require all the 100 files. So I don't wanted to leave any one of the file out of there. So at that time, if I wanted to use all the file from the first file to last file, then the serial file organization method will be very good method. So what are the advantages we can get out of it by using the serial? That is fast access to the next record. So if I'm done with the first record, I can directly go with the next record. So the faster accessing to the next record, and also stored in economical storage media. So it is not so expensive in order to store this serial arrangements of a file or record, and also it is easy to do the file backing up facility. So if something goes wrong, if some natural disaster happen, at the time who is going to take care about our files which is already stored in the computer? At the time it is necessary to have a backup file. So in the serial file organization also we have a backup file, so that if something goes wrong with one file, I can get another copy of the same file. That is one of the advantage. And also we'll see the next type, that is what? Direct access file organization. Direct file access. That means you can see that serial, if I wanted to access the 17th, at that time what I have to do? I have to access all the 69 records, then only I can get access to the 17th record. But in the direct access file method, so we'll see direct access file organization allows immediate direct access to the individual's records on the file. I have a file, I wanted to access that record. At that time, I should not, or I no need to wait for my turn. That means if I wanted to access the 50th record in the file, at that time I should wait up to 49 should get clear. That is in the serial file organization. But in the direct file organization or a direct accessing file organization method, at that time I can access the 50th directly. How we are going to do that? It is of direct accessing file organization method. So there will be a privilege of asking or accessing the record which you wanted in order to do some of the data processing things. So the type of storage device is comparatively expensive because it is giving, or when you have more priority or when you are going to get more features than the existing one, at that time it will become expensive. In the same way, if you consider the serial data processing or serial file organization, at that time, so that is somehow reasonable or economical. Why? Because if I wanted to access the 80th file, I have to wait up to 79. That means it will going to fetch our time. So, but in the direct access file organization method, we are getting the records or we are getting the file whatever we want. That is what? It will be expensive in nature, and also it is less efficient in the usage of storage space compared to the sequential organization. So why? Because if I am accessing any of the file, at that time that storage space will going to be empty. So it will going to be what? It is not so efficient usage of a storage space. So if it is sequentially ordered, or if it is serially arranged one by one, then there will be no chances of misusing the storage space. But here we have a direct access. If it is accessing, then that space will going to be what? Not so efficiently used. That is why it will be considered as what? Less efficient than the serial or a sequential file organization. We'll see the next type, that is related to self-addressing. So here it is giving the address, it is giving the index to itself. So how it will going to do? In self-direct addressing, a record key is used as a relative access or relative address. So here what we are going to use? We are going to use a record key. For example, you all consider. So here I have 4 records. Let me consider 1, 2, 3, 4. Okay. So this is self-addressing in the sense by default it will going to give the indexing for itself. For example, it will consider this as 1, 2, 3 and 4. It is only giving the address to itself or index to itself. Then how I am going to use this self-addressing mode, self-direct addressing mode? So record key is used as a relative address. So we are going to have a record key. So this is the record key. So that means record key 1, record key 2 and record key 3 and record key 4. Okay. So when I am using this self-addressing method, if I get to know the address of first file or if I get to know the address of first record, then it will be easy for me in order to access the remaining file. It is somehow like a base addressing. That means if we get to know the first address or first location of a first element of an array, then I will be able to get the address of further elements. Same thing will going to take place in this self-addressing. And also in self-addressing, no need to store an index, because here you no need to store 2, 3, 4. because if I get to know what is the first address where it is where it is storing in the file, which record is storing in file, in which index, if I get to know its address, then no need to bother about remaining address. Okay, so if I get to know this is the first, then the remaining will going to be in the sequential order. So that is the advantage. But if you consider the disadvantage, the records must be of fixed length. If someone records are deleted, the space will going to be empty. So if you consider here, it needs to be what? Fixed length. So that means I'm considering this as a 4. If I get to know the address of first index, then it will be easy for me to get to know the link of 2, 3 and 4. So if I deleted this address, or if I deleted the content of this 3 or a third index, at that time somehow this memory utilization is not going to be managed well, so that it will becomes empty. So at that time, how it will going to look like? So we have 1, we have 2 and we have 4. This remains empty. At that time, the proper memory utilization will not going to be taking place in the self-addressing. Next, we have a very important topic, that is index sequential access method. In short, we will be calling it as ISAM or ISAM. Okay, this is very important question in the perspective of your examination. So here you can see that it is a combination of both indexed as well as the sequential file organization. Already we have discussed regarding the sequential as well as the indexing, right? So sequential in the sense 1 by 1. Indexing in the sense I can go to the place, or I can fetch the record of my choice or based on the index. So when it will be collaborative, both of the methods, then that will be considered as what? This indexed sequential access organization or a method. The index sequential file organization is a combination of sequential file organization and an index file. So sequential in the sense what? It will going to be 1 by 1. Accessing of the content will going to be 1 by 1. For example, consider 1, 2, 3, 4. So I can access 1 by 1. What if I wanted to access the third one? I can directly access it with the help of this index file. So then further it will be carried out with the help of this sequential method again. So that is a combination of both sequential as well as the index file. So when it will be useful, if I have a large number of records. So consider I have 1,000 numbers of records. I'm in the 12th or I'm in the 10th record, but I wanted to access the 50th record. At that time, what I can do? I can directly access this method. So whatever is there further, then I can jump from one, that means I can jump from one record to another record. I can sequentially access it, but I can access to the location where I want. So further that indexing, it will going to be sequential in nature again. So, data is stored physically in adjacent storage locations, and there exists a logical relationship among the data which is stored by the ordering field. So, here also data dependency is there. So, one data will going to be located adjacently. That means if I get to know this is the address of this particular value or a particular record, then next content will be the address of next record. It will going to have a adjacent storage locations, and if it is adjacent, that means one after another, at that time it will going to have a logical relationship among the data which will going to be stored using ordering fields. And also an additional file called index file would be created which contains n number of records. So along with the sequential method, I can also have a index file. So that will going to have a record or a list of all the file. For example, 1, 2, 3, 4, 5 like this. So if we created this index file, then it will going to help in order to store or in order to contains the any number of records. There is no restriction. So for example, if I wanted to store thousands of records in a particular index file, we can do that. This is related to index sequential access method. Now we'll see about the advantages and disadvantages with respect to this index sequential access method. So what are the advantages that we can get with the help of this? So it will help in order to permit the efficient and economical use of sequential processing technique when the activity ratio is high. So when we have a high activity ratio, at that time we can go with this ISAM. So it will going to provide a very efficient and economical usage of a sequential processing technique. That means if you have thousands of records in a file, at that time we can process one by one in a sequential manner. So that is also one of the advantage. But then what are the disadvantages that we can expect from this ISAM? So files must be stored in direct access storage device. So when we are storing it with the help of direct access storage method, then it will be expensive. So we are going to have expensive hardware as well as the software resources that will be required when we are working with this ISAM. Along with that, access to records may be slower than the direct file. So here we are accessing it with a sequential file methodology, so that if I wanted to access the 40th file or a record, at the time I have to wait till 47, so that it will take more time, then it will be slower in the accessing. So less efficient in the use of storage space than any other alternative. So if you consider this method with any other alternatives methods along with a storage perspective, at the time it will be considered as what? Less efficient. This is regarding ISAM. We'll see the next topic that is related to different types of architecture. So as we all know that database management system will going to be based on the different kinds of architecture. So based on that, we can expect what kind of the features that we can get with the help of this DBMS. So that the design of a database management system, in short, we will be calling that as the DBMS, will going to highly depends on its architecture. It mainly depends on its architecture. So it can be either centralized, decentralized or hierarchical. So why we are saying this? Centralized in the sense what? It is like a hub. So some person will be there. They are going to take care about all the connected devices. They are going to have a control over all the connection. But if it is decentralized, nobody controls nothing. That is decentralized. And we have a hierarchical, one main authority will be there and remaining will going to be controlled by them. It is like a tree-like structure. So based on this architecture, we have three types. It is easy to remember. One is logical one-tier architecture and logical two-tier architecture, and also we have a logical three-tier architecture. So this is also called as client-server architecture. This is logical three-tier client-server architecture. We'll see about the first type, that is related to logical one-tier. So when it comes to the logical one-tier, so as I told, we are going to design a DBMS based on an architecture. Main intention is what? I wanted to access the content of DBMS. For example, you consider yourself as a client. You want to access the content of a database. So there will be three privileges, like I can go with a one-tier, two-tier or a three-tier. So when we are working with one-tier architecture, then there will be a privilege and it will be a permission to access the database content directly without any interventions or without any middle layer. So that is the main thing related to this first or one-tier architecture. So that DBMS is the only entity where user directly sits on DBMS and uses it. With the help of this one-tier architecture, I can directly fetch the content whatever is there in the DBMS. So if you see this image, here all the clients can have the direct access to this database management system. That is one-tier architecture. But you have to remember one thing, if any changes that has been made with this DBMS will going to be appeared or it will going to be directly affects on the DBMS itself. That means we don't have any other backup copies or we don't have any intermediate things in between the client and database. Whatever we are making a changes to the database, that will directly affect the database itself. It will not going to provide any handy tools for the database designer or mainly for database programmer. So they are going to use this one-tier architecture. That means we don't require anybody's intervention in order to access the content of DBMS. We'll see the second type, that is two-tier architecture. It is also called as what? Client-server architecture. So being a client, we are going to request something, and being a server, it will going to serve the purpose or it will going to serve the request of a client. So that is related to client server architecture. But here we have a 2-tier. That means 2 layers will be there. For example, if I wanted to access the content of DBMS, that is directly not possible. So with the help of this middle layer, layer, we have to access the content from DBMS to client. We'll see about that. 2-tier architecture or a client server architecture is used for user interface program. We are going to use this 2-tier architecture for the user program interface and also application program that will run on the client side. You can take the example of any social media. So at that time, that is also one of the application program, right? So if you wanted to use WhatsApp, or if you wanted to use Snapchat or any of the Instagram, at that time, do you know how it is working internally? No, but we are getting all the content whatever we require. So that is the same thing will going to be happen with this 2-tier architecture. We are accessing the content, but we don't know what is happening inside. Then who is going to act as an intermediate layer? That is ODBMS. That is interface will be called as ODBC. ODBC is nothing but Open Database Connectivity. This will going to act as the intermediary layer between the database server as well as the client. So you can take that here ODBC will be there, that is Open Database Connectivity. So this will get to know what are the abstract thing that we have to made in between the clients as well as the database server. As you all can see that it is bidirectional. That means whatever the content is there in the database server will going to be fetched and it will going to reach to the client in order to satisfy their requirement. If client is sending any of the requests, that will going to be reached to the database server with the help of this ODBC. This is an interface. It will going to act as a middle layer between this client as well as the database server. So mainly this ODBC will going to provide an API, application program interface, that allows a client-side program to call the DBMS. With the help of this, we can access the content whatever is present in the database server. And some of the DBMS vendor will going to provide the customized DBMS or customized ODBC in order to access the content of database server. So it may include data dictionary and optimization, etc. So we'll see the last type of architecture, that is 3-tier, that is also called as client server architecture. Here also we have a client server methodology. That means what client will going to request for the data and server will going to serve that purpose. So that is related to 3-tier. So here we have a 3 layers, and here also you can expect one of the intermediary layer. So whatever the content is there in the physical data or whatever the content is there in the DBMS or a database server, that will going to be reach out to the customer with the help of this application server or a web server. So this application server or a web server will going to access the bit of content or a piece of content which needs to be reached to the client. So it will going to have more abstraction than the 2-layer architecture. It know what needs to be sent to the customer or a client and what needs to be fetched from the database server. That is the 3-tier architecture. So here in this architecture, it is the most commonly used type of architecture for web applications. So we are going to use this 3-tier architecture for the web application. So whatever you are searching over the internet, you are going to get the data. So but do you know from where you are getting all those data? Who is sending all those data? Do we know about that? No. So from which country it is coming, from which page they are fetching, we don't know anything about that. We don't know where the database is locating at all. But we are getting the data as soon as possible. Why it is happening? With the help of 3-tier architecture, because we are going to use this 3-tier client server architecture in order to develop web applications. So if it is a web applications, then it will we are going to create a website, then it will be a collection of web pages also. And also here we have an intermediary layer called application server or a web server. So we have an application server or a web server. that will going to act as a intermediary layer. So that stores the web connectivity software and the business logic. Important terminologies you have to remember. One is web connectivity and another one is business logic. Who is going to hold this data? That is in the application server or a web server. So this will going to hold the business logic as well as it will going to hold all the data which is related to web connectivity. When it is having a business logic or when it is having a connectivity data, at that time it know what needs to be sent to the client from the database. So there will be more abstraction in the 3-layer architecture. And also this is a part of application which is used to access the right amount of data from the database server. It will going to access only the right amount of data. That means it will not take more, it will not take less. Whatever the requirement of a customer is there, based on that it will take the data and information from the database server. And also this acts like a medium for the sending partially processed data between the database server and the client. If I wanted to access any data in between database server as well as the client, or this application server or a web server will going to provide that methodology. This is related to 3-tier architecture, that is 3-tier client server architecture. So we'll see the next topic, that is related to database models. So till now we have discussed regarding the architecture. So now we'll see about the database model. So data model is a collection of conceptual tools for describing data, data relationship and data semantics and constraint. What is this data model is all about? It is a collection of conceptual tools. That conceptual tools are used in order to describe what is data and what is the relationship between one data to another data and what is its semantic, how it is representing along with its constraint, that is what are the rules and regulations that it has to follow when it has to be an entity or whatever it has to be in the DBMS or a database management system. So when we are having all these description in the conceptual tool, then that will be considered as a data model. So it mainly consists of 2 points. One is data model theory and another one is data model instance. So data model theory in the sense what? It will going to have a formal description of how data may be structured and used. So it is like a theoretical part. It will going to act or it will going to have all the theoretical aspects which is related to the data and how it needs to be used. But what about this data model instance? That means we are converting this theory into practical format, that is data model instance. So which is practical data model designed for a particular application. So we have a theoretical part, that is data model theory. So we are going to use this data model theory in order to convert the data model theory into practical description about any of the application. That method is called as what? Data model instance. We are converting data theory to data instance. Then that process is called as data modeling. So you can see that the process of applying the model theory in order to create a data model instance, that is known as data model or data modeling. And we have 3 types in the database model. One is hierarchical model, network model, and we have a relational model. We'll see about the hierarchical model. So as the name indicates, it is related to tree-like structure. Hierarchical in the sense, it is tree-like structure. So in the hierarchical data model, which will going to be organize the data in tree structure. So if it is a tree structure, then there will be one root node and remaining will be the children of that particular root node. It will going to have a parent-children relationship. And also in this data model, data is represented by a collection of records and the relationship are represented by links. So if you see this, we have a records called, we have a student record, we have a professor record, course record as well as the department record. How one entity or one relation is collaborating or having a relationship with another entity with the help of links. So you can see that this will be considered as a links. So this will going to establish a relationship between one entity or one record to another record. And also in this model, each entity has only one parent. So if you see this, if you consider the department, it is the only root node. This is the only root node. It can have any number of or several number of children. So all these student, course as well as the professors are derived from the department. So here department is considered as a root node, and all these like a student, professor and course will be considered as a children of that particular root node called department. And also at the top of hierarchy there is only one entity which will be called as a root node. As I told, department is the root node in this entity. We'll see the advantages of this hierarchical model. Mainly of it is related to simplicity. Why we are going to call this as a simplicity? Because here we have a tree structure. One parent class will be there, or one parent entity will be there, and it can have any number of children nodes. So that will be considered as simplicity. The relationship between the various layers are logically simple. It is one to many. Only one parent and it can have many number of children. One to many relationship, and also it provides a data security, then data integrity. That means we are checking the correctness or a truthness of a data relationship. So here if you consider this, one entity will going to have a relationship with another entity with the help of or ensuring the link between those entities, so that it will going to have a data integrity and efficiency. So in what way it is efficient? It is very efficient because when the database contains a large number of one-to-many relationship, main thing is what? One-to-many relationship. When you wanted to maintain the one-to-many relationship in the database management system, at that time we can go with this hierarchical model. So now we'll see the disadvantages of this hierarchical model. What is the first disadvantage? Implementation complexity. Anyway, it is one to many, though it is complex. How? Because we have to concentrate and we have to choose which is the parent node and which are the children nodes. And also database management problem. Management of all those data will going to be somehow difficult, and lack of structured independence. So there is no independence between the data entity. So if a department is also going to be depends on a student, course as well as the professor, so there is no independency, so there will be a lack of structural independence and also operational anomalies. So these are the disadvantages. We'll see the second data model, that is related to network data model. So if you consider the first type, that is hierarchical model, it is like a tree structure. But if you consider this network model, it is like a graph structure. That means one node can have a relationship with any other node. So if I wanted to reach any of the node, there will be more than one path. So and it is also considered as what? Many to many relationship. We'll see now. So in this model, data is represented by a collection of records and the relationships are represented by links. Here also we have a different entity called student, department, course as well as the professor. So if I wanted to have a link between one entity to another entity, there also we are going to use links. So this will be the network data model, and here each record is collection of fields. So we have a collection of fields and which contains only one data value. For example, if you consider this ID is one field, this name is one field, course is one field, student is one field. So it will going to have a different collection of fields and which contains only one data values. And a link is association between the two records. So if you consider this link, it is giving a association or relationship between this professor and a student entity. So that will be considered as a links. And these are the attributes or a fields. In the network model, entities are organized in a graph. So if you consider a hierarchical model, that is a tree-like structure, one-to-many relationship. But if you consider this network model, it is many-to-many relationship. There will be, that means some entity can be accessed through several paths. For example, I wanted to have the content of this department from the professor. How can I do that? I can reach this way, I can reach this way in order to get the department, or else I can go from here, I can get it, or else directly I can have a relationship between this professor and department entity. So this is how we are going to work with this network data models, and it also has some of the advantages that includes it is simple and easy to implement, because here it has a many-to-many relationship. Somehow it is both advantage as well as disadvantage. So if you consider that, it will be simple and easy to implement, and also it can handle many relationship within the organization. So when you wanted to have a many-to-many relationship among the entities in an organization, you can use this data model in order to implement that scenario, and it has a better data independence compared to the hierarchical model. So here you can build a relationship between one entity to another entity. So that means what? Somehow there will be a data independence. For example, if you have a hierarchical model, one root node must be there and remaining will be children node. So all the children node will going to be depends on the root node. But here that is not the thing. That is why it will going to have a better data independence. But what are the disadvantages I can expect from this? Here it is more complex system of database structure. So many-to-many relationships. So we have to build in all the dimensions. So somehow it will be going to be more complex than any other system. Lack of structure dependency. So as I told, there will be data independency, so that there is no dependency between one entity to another entity. We'll see the last type, that is relation data model. So we got to know what is hierarchical and what is network. So then what is the speciality of having this relation data model? Hierarchical tree-like structure, and it is one-to-many. And we have a network data model that is many-to-many, that is graph. But in the relational data model, without having any of the links or any of the association between one entity to another entity, here we are combining or we are collaborating from one entity to another entity, which is based on the table format. That means we are going to use a tables. Tables is also considered as relations. So if it is a table, then it will be a combination of rows as well as the column. So the relation data model was developed by E.F. Codd in the 1970. Here there will be no physical link between one entity to another entity in the relation data model. Why? Because all the data is maintained in the form of table. Tables is also called as relations, and it consists of rows as well as the column. It has both rows, it has both rows and columns. So each row, that is also considered as record, represents an entity. So if you consider here, it represents an entity, and we have a column considered as what? Field or attribute of that particular entity, that represents the attribute of the entity. For example, consider an entity called professor. So whatever the value I am going to give, so that will be the row or a record. So CS.1 and course is BCA. So if you consider this one, so this represents the record, that is also called row, and it has a unique fields. Fields are attribute that specifies the characteristics of an entity. For example, we have a professor, it has a professor number and their name, and they belongs to which department and what courses they are taking. So those are the attributes or a fields. So in this model, data is organized in the two-dimensional tables. So that's why it will be called as relations. So it has both rows as well as the columns. So here, instead of having a physical link in between one entity to another entity, we are simply having a relationship between one entity to another entity, which will be based on the common attribute or a common field among those two. So here you can see department number, and you can see in the department we have a number, and even in the professor we have a department number. So these two will be the common field in both the department as well as the professor. So then there will be a dependency between department as well as in the professor entity, but we are not creating any physical link. So now we'll see what are the advantages that we can expect out of this relation data model. So the relationship between the two tables is implemented through the common attributes, so no physical links or pointers are used. So we are going to have a common attribute or a common fields between two entities. There is no physical links or pointers are going to be used, and also querying much easier in the relational database. So asking a equation or building a equation between one entity to another entity somehow easier. And relational model has more programmer friendly and much more dominant as well as popular. So here no dependency, so that it will be much easier, and it is also going to be used more by the programmer because it is so friendly. That's why. And we have some of the examples which is related to this relational data model. It includes Oracle, Sybase, DB2, Ingress, Informex, and also we have a MS SQL server. So these are the examples which comes under this relational data model. I hope you all understood. It's all about today's session. Let me meet you in the next session with a continuation of this chapter itself. Until that, you all keep learning, keep on growing. Thank you.